Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello and welcome to this week's episode of the DooDoo Diva Smells Like Money podcast. We are here with Eric DuPre. For those of you who did not tune in last time, this is second in a three-part series where we're visiting with Eric, who is a very, very wise guru in the field of SSOs and I and the wastewater industry in general. So without further ado, I welcome Eric, founder and president of the Texas Infra Group, back to the center stage on the podcast. Hey, Eric.
Hey, Suzanne, how y'all doing today?
Doing great. So last time we were talking about, asset assessment and condition assessment and needing to know the importance of the actual condition, which led me into, you were saying the condition and the structure, but then it's leaking like a sieve. And so one may actually be more important to address than another. And so with that said, we talked offline about sources of rapid leaks. And most of us are now becoming aware that even though we've closed off a lot of I with mainline CIPP lining or replacement or spot repair and whatnot, there is still a great degree of I coming into systems that, I think they're attributing it's like 70% is coming from house laterals, which obviously we can't address that. But then a lot of it is coming from other structures, manholes, wet wells, lift stations, but manholes are a big culprit, and they've often been neglected. They're just there. There's something in the street. We drive over them and hear the dunk, and we really don't care about it much. And so I'd like to focus this episode on the little manhole and how important the manhole is. And even more important, how critical the lid and the ring and the entry point to that manhole is as it relates to the entire collection system structure and the health of it. And so without further ado, because this is really your wheelhouse, let's give some praise to the lowly manhole.
Well,
let's give it some love. We need to give the manhole some love.
Well, what's funny is the most iconic symbol in the sewer system is the manhole cover. It's the first thing you see to gain entry and access into the system. And it's also, according to the EPA, the way that they account for a discharge is when the sanitary sewer and sewage discharges out of that particular location. So it's for years and years, I'd say easily 400 years, the casting, the manhole cover has been very simplistic in its design. And when we built these brand new systems years and years ago, we had a lot of water storm sewer systems combined. So the thing is, when they were built brand new, you didn't have near the issues of hydrogen sulfide. You didn't have the volume at the very beginning of building our infrastructure. You just didn't have that kind of volume. And you had a mixture of water intake and sewer intake. And so when you had the solution is dilution, to dilute the sewer, you have a lot of oxygenated rich water flowing in a sewer system. So hydrogen sulfide was not really a big issue. When the EPA in the 70s started cracking down and saying, hey guys, we no longer want to pollute and join forces of our fresh water or any of our water sources. We don't want the sewer and the sanitary sewer commingled and mixed together. That's bad. We don't like that because people are getting sick. It's going into our fresh water. And what was happening too is that, especially in my home state of Texas, we started getting away from pumping groundwater. And now the regulatory agencies want us to go to surface water. So now that we've converted more so to surface water and using a huge percentage of surface water, it makes this even a bigger issue because every time you have a discharge of sanitary sewer that comes out of the system, it automatically goes into the storm sewer system and goes into your rivers, your lakes, your creeks, and all the places where we're getting our surface water. So EPA, again, being from Texas, I know the policies, I know what's happening here. We have probably more EPA SSO consent decrees than any state that I know of right now. I mean, it's San Antonio, it's Houston, Corpus Christi, Tyler, Texas, Beaumont, Texas. Like,
why is that?
Well, geographically, wet weather events. So,
okay.
So when you have a wet weather event and you have an old age leaking sewer system that can intake a massive amount of intake from inflow and I, these rain events overcapacitate, fill up the collection system. The collection system's in full, and then it purges out at various locations of the system. And that's when you get what's called an unauthorized discharge, which is raw sewage breaching the sewer collection system before it can make its way to the treatment plant. So something I was kind of thinking about this week was, there's so much emphasis on the wastewater treatment plant. You have sensors, reports, you have to be certified, you have to have all this stuff going on at the plant. And it's ultra critical to process this water, make sure it's clean so that it properly discharges into the creek. And that's at one single location. That's just at the plant. But the sewer collection system that's outside of the plant, it doesn't have any of those rules and regulations to the extent of the sewer plant, but the living environment and the humans and the people that live within the actual collection system, the people don't live at the sewer plant. They live and breathe in the environment of where the collection system is, but there's hardly any emphasis or requirements, stringent requirements that you have at a plant. But when those sewer systems overcapacitate, it's raw sewage, bacteria, fecal matter that is discharging into our living environment. And the environmental impacts that it's having just in Houston, Texas alone, we had accumulated $18 billion in SSO fines. $18 billion. So they came to the bargaining table and they negotiated to come up with a plan to fix our sewer system in Houston, Texas. And they negotiated of actual money spent on the direct sewer system of $2 billion versus spending $18 billion in fines and actually not fixing anything. So EPA in Houston, the attorneys and the whole 9 yards, they got together and they've agreed to come to a $2 billion EPA consent decree. And but what kind of bothers me is this is our second EPA consent decree. We had one in the 90s. Mm-hmm. So the things that they did in the 90s, they didn't work. They didn't work effectively enough to keep us out of a second EPA consent decree within a matter of 20 years. The first one was in the 90s, and we spent billions of dollars, and that's where trenches technology, where Houston was one of the very first cities to have a big mega EPA billion-dollar consent decree. And so we learned some things there, but there was lessons learned and unlearned. And now those, in my opinion, some of those things are now being brought to light, which is the manhole covers.
Wow. So let's talk about that, because one of the things that you had mentioned, and it's a little bit of a little yuck factor, but that when you have the SSOs in the streets doing a big rain event, and then what people don't think about, maybe we need to think about it, but we try not to think about it, is that the water evaporates, but the stuff that was in that water gets left on the street it dries up. Like you were saying to me earlier, all that stuff dries up in the hot Texas sun, becomes airborne. It's dust. It's on the sidewalks. It's on the lawn that your kids are rolling around in, that the dog is rolling around in. It's on your driveway. It's in the air. And it can make you sick.
Yeah, this is a health hazard that there has not been any. I have hardly seen anybody doing any kind of investigative study. But naturally, if you think about this, you have raw untreated sewage that has discharged in. I'm going to pick on Houston just because I have the most amount of information and data. Is that when we get these, massive floods, depressions, hurricanes, or just big rain events, we flood out so much here in Houston because of the storm sewer system's not up to par right now either. So it's a double whammy thing. And so when you have untreated raw sewage discharge, okay, and it goes into the grass area, and you have it sitting there in the grass area, the water subsides into the grass, but the solids, the fecal matter, the bacteria, all this stuff is on the surface. It's left at the surface and it's sitting there. And then after it bakes in the sun for a couple of days, the guys come out to mow their grass. And when you mow the grass, now you spread this stuff airborne. So it's a massive health hazard that I have seen little to none studies on what the health effects are. But rest assured, when you canvass that much raw sewage and fecal matter and bacteria, like toxic bacteria that's supposed to be treated, but it's in our living environment, and we cycle this season after season after season, that's got to make people sick.
It just makes sense.
So
makes sense. So
I can't speak to the degree because there's not enough data about that part of it, but I'm just letting people know that if you have years and years and years of this reoccurring, and it is reoccurring, I've got photos, pictures, all kinds of stuff, because you can't avoid these rain events in some of these geographical logistical locations. So from the point of Brownsville, Texas, if you were to follow the coastline all the way around from Florida to the Carolinas, all the way up to Maine, we get all these same reoccurring seasonal rain events. We get snow events where the snow melts. These are the things that happen in other areas too. But the point is, getting rapid I into the sewer system. I showed you a quick video of the most standard cast iron manhole cover that is nationwide along these coastal areas. They're not sealed. They don't have any seals. They don't have any gaskets. They usually have vent holes or pick holes in them. And when you get these rain events, the amount of water that can come through a single manhole cover in a 24-hour rain event can be as much as 65,000 gallons in just one 24-hour rain event, just one. So when you do the math, like, again, if I want to pick on Houston, we can go big on Houston because they have approximately 140,000 manhole covers. So if we took 140,000, I got my simple Casio calculator out here. So if we took that and we said that I know for a fact at least 90% of those are defective, that still puts you at 120,000 manhole covers. Let's just be very conservative and just divide that by 4. Let's just say 1/4 of those receive an exponential amount of inflow. That would leave you with approximately 31,000 manhole covers. And if they're leaking at what we already tested with Louisiana Tech, we made a water box and we tested it and it yielded 45 gallons per minute. So in a 24-hour rain event, that yields 65,000 gallons. So I'll multiply 65,000 gallons times 31,000 defective manholes. That's 2 billion. That's 2 billion with a B gallons of rainwater that entered into the city of Houston sewer system in one single rain event. Now, I've also done the math on the approximated capacity of the sewer system volume, dry without any sewer in it whatsoever. The city of Houston's capacity in their collection sewer system is approximately 1 billion gallons. So if they can receive 2 billion gallons in a 24-hour rain event, and they only have the capacity for 1 billion, that means within half a day of that, in 12 hours, that system is already maxed out in its system. So then what happens is SSOs and discharges start happening, randomly throughout the system, wherever the low spots are at. So, and that's just the quantitative fixed amount that can physically leak through just the existing manhole covers that they have. That's not the adjustment ring. That is not a lateral. That's not a pipe. That is just the actual manhole cover. That most of these covers are 40, 50, and 60 years old anyway. They're going to have to be replaced, and none of them meet current TCQ or TCQ or EPA design standards.
You had mentioned that the EPA is hoping for us to get to a closed system for our underground collection systems, which, probably not going to happen in my lifetime, or, well, you're a bit younger than I am, but, that would be a huge undertaking, but that the goal would be just by a little bit to make some progress, if not perfection on this, and get as much of that inflow out as possible, or prevent it from entering the system, which leads me to, if we look at just manhole cover design, which, we just talked about, that is a huge culprit.
Yeah.
Not that it means to, it's not doing the poor little manhole, it's not doing it on purpose, but just from the nature of it, it's an easy target for water to enter the system. And so, because you're the expert on this, share with me some of the advancements in just manhole cover design, that iconic thing that we all know and love, that would actually, by just a shift in the design, how this could really impact I.
Yeah, so I have studied all the major SSO programs, impacts. I've read all the data. I've looked at university data. We did our own R&D testing to find out how bad these were leaking, so that we actually had it done at the universities with engineers, so that we could sign off on all this stuff. And so the technology materials that we had 200, 300, 400 years ago, it worked great when the systems were designed with those initial intents of having storm sewer and sanitary sewer. But EPA has said, look, we want to keep these systems separate because of health reasons.
Right.
And because we really have to, and we need to keep these systems separated. And knowing that sewer and raw sewage and fecal matter and bacteria, these are toxic materials that we have to live with. And so we need to keep those separated out of our living environments. And so it's never going to be a perfect sealed system, but we want to buy enough time and enough capacity so that the sewer stays in the sewer system during a rain event, where maybe it floods and maxes out the system, but it doesn't overcapacitate it so fast and easily and quickly. So truly what we're trying to do is buy time. And so, so when we want to buy time, and then we also want to do an upgrade to the system, we want that best bang for the buck. How can we eliminate the most amount of rapid inflow that comes and pours into the system directly for the least amount of dollar to make the biggest impact? So what's cool about it is not only are you making this environmental health impact by sealing it up through the manhole covers, for every 1,000 gallons that you eliminate out of the sewer system, it's approximately about $1.25 to treat, to process it with electricity, to process it and pump it through the collection system, the lift station, and make it all the way to the sewer plant. Once it gets to the sewer plant, you have millions of billions of gallons entering into your treatment plants, and now you have to treat rainwater. And the cost of this is in the millions, in some cases annually billions of dollars, depending on their size. So now we're talking about economics and health impact, where if we do the quantitative math on the cost and the environmental and the health risk, and you put those all together, it makes the priority and the subject matter of the manhole cover a very public, what I would call public enemy number one. Like, this is your biggest culprit that can make the most amount of impact for the least amount of cost. You don't have to dig down 20, 30 feet. You don't have to do a whole lot. You just have to merely replace an old aging asset that you already know. Number one, it's not if you're going to replace manhole covers, because you are. You already know you are, because they're already at that life expectancy of 40, 50-year life expectancy. And when you analyze how much impact environmentally and health they're costing you, and then the physical financial cost, it makes it a no-brainer for you to want to go attack as many of those culprits as you can.
So what's the difference in the design of these new manhole covers? Like, what are they composed of that they have so many advantages over, what we've been using?
So the previous manhole covers, the majority of them don't have any sealed gaskets around the ring and the cover. And so anytime you want something to be sealed, I don't care what industry you work in, I don't care if it's mechanical on a car, if you want two things to seal and not leak up, 9 times out of 10, you have a gasket. So some kind of sealed rubber gasket, neoprene, some kind of material that is mushy enough to where when two surfaces meet, it can kind of compress and basically seal the two components up. And then, so gaskets are number one. That is something in the new design criteria. This isn't, this is something in 2015, the state of Texas changed the design criteria for manhole covers. They can no longer be vented. So in the state of Texas, the manhole cover has to be solid. Okay. It requires a gasket. And in some cases, it requires for it to be secured and bolted down. So the problem with the old cast iron bolt down units is they would use stainless steel bolts, but the unit itself is cast iron. So when you incorporate corrosion in two dissimilar metals, one becomes an anode and one becomes a cathode. The metals try to attack each other, and the stainless steel will not yield. So what will happen is a high level of corrosion will build up right against the cast iron threads. And when you have that amount of corrosion, it seizes them up. And when they go to unthread them, it destroys all the threads. So the bolts, after the first or second time you unbolt them, the corrosion has caused so much damage that renders it useless at that point in time. Now that you have a more sealed system because of design criteria at the manhole cover is the spot and the source of things leaking out. But more importantly, that's where an actual discharge will happen and occur. So if it's not secure, I've seen 250-pound manhole lids go skyrocketing into the sky because you've had hydraulic water pressure hit so fast and so heavy that it's literally, I have videos on YouTube and all over the place where you see cast iron that are not secured, they just get ejected. And so if they're not secure, you have the potential source of the water discharging out of it. When the unit becomes secure, bolted in place, and then has a concrete apron or pad around it to anchor it, secure it down, you will not have a discharge at that location. You may have a discharge 10 manholes down where you've sealed up like 9 out of 10 manholes, but the 10th one is not sealed on purpose so that it has an area where it can purge. But the owner can now, and the maintenance operations and owners can look at, okay, if it's going to discharge, let's find a more desirable place for it to discharge.
Okay.
Instead of the other 9 are at a park or at a school or in front of people's homes and things like that. If you have something that's out, not so much, in a working, living environment, you can have it discharged in a less desirable. But for every one that you actually sealed up, you now don't have any inflow pouring into those units too. So you've reduced you've eliminated 100% occurrence of an SSO. So you've checkboxed the fact that EPA, you've now satisfied an EPA requirement. They don't want an unauthorized discharge out of that location. So if you were to pick 10 manholes that you know were all leaking before, and you sealed up 9 of them, you're at 90% compliance. And of those 9, you're sealing out 65,000 gallons in a 24-hour rain event per manhole cover of those 9. And the only one that you have to contend with now is just the 10th one. And you can put it in the least or most desirable area, however you want to look at that. And maybe you put it in a field or next to something where you're going to get a massive amount of rain to have parts per million that are more desirable with the water. Because we're not going to get to a perfect system. So if we can't get to a perfect system, that we have to look at the next best option. And the next best option is meeting EPA requirements and coming up with an effective plan of where we have a more controlled discharge than uncontrolled random discharge. So the kicker to this is, now that we've gone to a sealed system and we no longer allow storm sewer and sanitary sewer to be commingled or combined, you just have sewer.
Right.
When you start choking off air in a sewer system, you get high levels of hydrogen sulfide. Hydrogen sulfide in cast iron, metal, and concrete materials, they do not play nice with each other, and they don't like each other because they have a chemical reaction. The binder strength materials in these materials and hydrogen sulfide corrosion, they just have a very, very abrasive, bad chemical reaction. And the concrete gets chewed so bad, it just turns it into putty in some cases, to where the structural integrity is gone. The cast iron doesn't normally completely chew through it to where it structurally has structural integrity loss. That's not the problem. The problem is the ring and the cover become so seized together because of corrosion that they literally have to break the covers off with sledgehammers, damaging all the concrete that seals it up and keeps it in place. And they start creating open sores and sources for even more I when they have to break open these covers. So the sewer systems with these new EPA requirements that have to be in place, they're going to have to start upgrading the materials to non-corrosive materials, which are the same things that your HDPE, PVC pipe, composite manholes. Composite manholes are 100% composite materials with no metallic substance in them whatsoever. So they will never seize up and corrode or rust and have the same issue that we've had with cast iron in this new evolving system.
So I take it there are multiple manufacturers that make these non-corrosive material sealed manholes for people to choose from. Okay.
Yeah, absolutely. There's 3 main companies that I know of. And just to show that the industry knows what's happening with cast iron, one of the largest cast iron manufacturers on planet Earth here in the United States that supplies the cast iron covers, they bought out a company that was making composite manhole covers. And now they are part of the future of making, because they see where the design and what's happening to the system, they see what's coming down the pipeline. So why would the largest cast iron guys go buy one of the largest, composite manufacturers here in the United States if they didn't kind of see that these things are needed when they change the design criteria for a more sealed system? You're going to have to change the materials. The design of the ring and cover is very, very basic, and they've made it robust enough where they've tried to use weight to overcome, forces and things like that. But corrosion, when they first designed cast iron and you could do storm sewer and you could do sewer, it was honestly, it was the perfect solution, because they got capacity for rainwater in their sewer systems, and they got capacity in their storm sewer combined. And now they're like, no, we can't do that. We can't do that anymore. So that design, now that it's been changed by EPA, we're going to have to change the design and the materials that we're using to build the future infrastructure.
That makes sense. Well,
So in 2016 and 17 is when I started the journey of seeing these things happen and seeing the design criteria, and had doing manhole rehab for 20 years. The first part of my career was the field guy doing the condition assessments inside manholes. So I had to pop all these manhole covers all the time. And I firsthand knew all the issues that I encountered in the field with this design or that design or whatever. So when we built these newer products that need to go into the future, we built it with all these things in mind so that we incorporated little tiny features that we know they'll be very, very important to the field operations, the contractors, and the people that have to, install the product. So being a newer product, not being well known in the industry, like composite manhole covers, 9 times out of 10, they're just going to go buy the same cast iron they've been buying over and over and over again, but they're also going to get the same results that they don't like over and over and over again until they get educated and see that there's new viable options. So it's 2022 now, and the first composite manhole cover that I ever put in the ground was like in 2016.
Wow.
And they're all functioning, and they've evolved just like all products do. Is you have your generation 1 product, and you see what it does out in the field, you see what it does in the ground. So we're like at year, what does that put us like at year? We're at like year
8,
6 or
yeah, almost 8, really.
Yeah, almost year 8. And we have a very high success rate. I have 0 recalls of any of the products not functioning properly. Some of them are banged up, dinged up, or a little bit, but you can go look at cast iron products, and depending how they were installed, if they weren't installed properly, they'll get banged up and dinged up as well. Because if you were to put them in roadways and you expose the ring, and the concrete or the asphalt is not quite up to the level where the rubber tire just rolls over the top of it, there's not much impact from a rubber tire just rolling over a smooth surface. It's only when you don't have an unsmooth surface and you have like a 2-inch gap and you expose the sidewall and you have a tire come hit it at a high rate of speed. So installation, just like any product, installation and the type of material that you put around it, we highly recommend concrete anchor pads around all of the units to where they're always flush. And so the other advantage that was kind of unknown at the time is that we needed to figure out a way to have a non-corrosive material.
Right.
That was key. We're like, look, like if they keep seizing up, we got to keep breaking them. Here's your first cost, but here's your second cost, and here's your third cost of every time we have to break these open with a sledgehammer, cause more damage, cause more. So you're looking at a life cycle cost of like, how much is that cast iron? Initially, the first one's cheaper, but the second and the third and the fourth one in the same time frame that you would have bought this other cover, it's a fraction of the price when you look at the life cycle over like a 10, 15-year span. But one of the unintended consequences of this was that smart cities, and I know we'll probably get into that in a minute. But
spoiler alert!
Yeah. So
the manhole covers are actually, they're going to be, and we're going to talk about that in our next episode, is that manhole covers are now going to be smart covers to give us even more ability to know what is going on with our system.
Absolutely.
And so with that said, I think we're at a good point here, because
okay.
I don't want to spoil it for the audience, but for those of you who are interested in knowing more about the subject, or maybe even just, conversing with Eric about this, because he certainly is the expert in this field and maybe give you some insight on how you can make the shift from what you may be using into these new non-corrosive smart covers that actually are going to save you money It'll, cost, like you were saying, it costs more at the beginning. But one thing we didn't mention is not just the cost of replacing that cast iron manhole over and over again, but what about the I that comes in from that cast iron that you won't have with these composite manholes? So in a way, if you think about your overall operating costs, it does pay for itself. So it's certainly something to really give serious consideration, that just because this is the way we've always done it doesn't mean that this is the way that we should continue to do it. And so, Eric, can you tell the folks that are listening in your website address, please, if they want more information about you and your company and some of these things that we've been talking about today?
Yeah, the best way, I like to share a lot of information and get input and educate the audience. And so the way me and you found each other was through LinkedIn.
Okay.
So
you can find him there?
Just if you Google Eric DuPre, Texas Infra Group, that should bring me up on just about any platform. I have a lot of white papers and a lot of content published on Trenches Technology Magazine, about manhole covers, Underground Construction Magazine. I've been publicized in a lot of those specifically on this topic over the last decade, pretty much. But Texas Infra Group, texasinfragroup.com, that's our direct website. The email addresses and the content there would come directly to me. But the easiest, fastest way, to be honest with you, if somebody's on LinkedIn, they can just connect with me on LinkedIn, and through LinkedIn, you can just do about anything you want as far as business to business, or like read stuff that I've already posted to see what information you can already ascertain to see, are these advancements that you want to do in your system? And if they are, we can have either a private or open conversation about the pros and cons of what you need to do to get up to code, up to standards. And here's the most important thing. The environmental impact and the health stuff is super important. But at the end of the day, I honestly know what is the most important and near and dear to their heart is the economics of the return on investment. And I've got that down to a science in an Excel spreadsheet that shows you, if you identify that your particular manhole cover is leaking X amount, we can extrapolate that in a data sheet to show you what that asset is currently costing you annually. Most of our upgrades to do the upgrade to the most common composite manhole cover is typically 36 months or less to get a break-even return on investment. Thereafter, since there's no more leaks coming in, you're not paying for electricity, you're not paying for treatment and chemicals, and you're not paying for a fine at that location for an SSO anymore. So when you combine the economics of the bang for the buck and the most impact on one particular asset, you will not find, trust me, I've researched, I've done a lot of stuff, you won't find anything that makes more of an impact specifically to I and SSOs that put money in your pocketbook faster as a combination of that particular upgrade. And if anybody has, I would love to hear it, because let's just say somebody found something else, but in combination with the two of those things, you can say, if we were to attack this asset and this asset, we would knock out, a tremendous amount of I and SSO and avoid a lot of these, additional costs. Those additional costs are just eating people alive. And I'll add this. We get a lot of these rain events along the coastal areas from Florida to Texas easily, and even the East Coast, when we have big hurricane seasons. And so you have to think about this. During the hurricane seasons, how hot is it? You know how hot it is during those seasons? Okay, so let me ask you this. ERCOT, like in Texas, we have it's called ERCOT, which is like an energy efficiency breakdown about the rolling brownouts and the rolling blackouts. We could reduce so much I and I. Guess how much electricity you could reduce during the hottest time of the year?
Wow.
Do you know what kind of electrical impact that would have on a grid if you were to canvas a whole area to where you could lock out massive amounts of inflow that you don't have to pump and treat with all those massive pumps. Those pumps are not small.
No.
If you were to go look at some of these large lift stations in Houston and these wastewater treatment plant pumps that they use, and these things are blowing and going wide open during the hottest time of the year, that's the perfect time of the year to try to alleviate the system, come off the electrical grid. So the impacts are exponential in this one single upgrade that in all my 20 years of doing manhole rehab, I can't tell you of another asset that would make more of an impact.
Wow. As my father always used to say, Susie, run the numbers. The numbers don't lie.
They don't
Numbers never lie. Well, on that note, because I want to save some of the really juicy bits for the next episode, as we're going to continue this dialogue about manhole covers. And it's even going to get more fascinating. You know, I love how we're giving this lowly little part of the sewer system some love. It's been needing some love for a long time. So thank you again for tuning in. Thank you, Eric, for being here with me. And we'll see you on the next episode of the DooDoo Diva Smells Like Money podcast. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.